ഓൺ ചെയ്ത് വെക്കാലോ എന്റെല്. So, good evening, one and all. Am I audible?
Yes, Vaidehi.
Okay. So, good evening, one and all. Today we'll have this is Vaidehi from Ancrom Enterprises. Today I will be delivering a short presentation on DPPH. Start the presentation. So, before starting the presentation, I would like to say that we'll have a very short presentation about how to perform DPPH assay. Along with that, we'll have a live demonstration on how to actually perform DPPH assay. Okay, so let's first understand what is HPTLC. So, HPTLC stands for High Performance Thin Layer Chromatography. So it's an analytical technique which is used for the separation of components from the complex mixtures that provides high resolution separation, simultaneous analysis of multiple samples, and versatility in detection methods. Also, it gives you reproducible and reliable results with a minimal sample preparation. So these are the different modules that are required to perform HPTLC. As you can see, there is an applicator. By using this applicator, you will apply samples onto the plate. With the developer, you will develop the applied plate for the development of the sample. Then for image capturing, we have visualizer. So you can see the output that you get by using the visualizer. Next, we have a scanner to scan the stationary phase so that the separated bands you could get into the peaks. Then then you could also hyphenate this HPTLC with MS interface so that you can study the characterization of the particular component that you want to study in detail. Uh, Apart from that, you also have derivatizer. So basically, if your components are not UV active or fluorescent active, you can also derivatize the plate. All this module is been connected by all these HPTLC modules is been connected by one single software, that is VisionCat's software. Okay, so we'll see how the we'll now see the stepwise practice of HPTLC. So first step is sample preparation, like the sample that you have, whether you have a raw sample or you have an extract sample. As per USP, you have to follow the sample preparation method. Then there is the selection of the stationary phase. Once you have selected the stationary phase, for the sample application, you have an applicator followed by the chamber for chromatographic development. Capturing of the images, you have image documentation. And for this further scanning or document or for the quantification, you have a densitometric scanning. So this is one part of HPTLC. And if you want to study, like if you want to characterize the further samples that you are interested in more detail, then you can hyphenate this HPTLC with other techniques like mass spectroscopy. There are NMR, also other assays which are available for such as assay for alpha and beta glucosidase. We have for alpha and beta for to study the anti-diabetic property, we have alpha and beta glucosidase assay. But in this webinar, we'll be focusing upon DPPH activity of the DPPH activity. So we'll first see what is DPPH activity, how it works, and then we'll see the actual analysis. Okay. So the basic principle of DPPH is what? So DPPH usually it's a free radical. Free radical, which means it is an unstable molecule. Unstable molecule, they are highly reactive. So when you can see in this picture, this is a which is an unstable molecule. It can react. So to stabilize this molecule, we have an antioxidant. So which means this antioxidant will donate an electron and it will form a stable molecule. So that is the principle, that it refers to the reduction of unstable DPPH molecule, and by with the help of the antioxidants, this molecule will be converted into a stable DPPH molecule. Okay, so that is what we are going to study. We are going to study the antioxidant activity of the component that we have to analyze. So now let's see the free radicals. So free radicals are what? They are nothing but the unstable molecules that are formed during normal chemical metabolism. So when they get accumulated in the body, they are going to damage the important cellular components like DNA, lipids, and proteins. But what these antioxidants do? So, what you the foods that are rich in antioxidants. Okay, so the food that you consume, they are rich in antioxidants. They are going to attack these free radicals, and they are going to protect the cells from the damage that are being caused by these free radicals. Okay, so this is what I have this image explains. So this is a stable molecule, and now with the during the normal cell metabolism, this stable molecule is now formed into an unstable molecule. Okay, so when you consume foods like leafy vegetables, let's say, so this unstable molecule will be now into a stable molecule. Why? Because the antioxidants, because they are rich in sorry, the leafy vegetables, they are rich in this antioxidants, they are going to pair the electrons. Okay, so DPPH, so now talking about DPPH itself is an unstable molecule which is in violet in color, but when it is been reduced by the antioxidant, it becomes a stable molecule. So there is a color change from purple, violet to yellow color. Okay, so now we'll see DPPH activity, how DPPH activity is performed. So let's say DPPH activity, that is a reliable method for evaluating the antioxidant activity. Okay, so DPPH activity, it is very simple, fast and reliable method to study the or to assess the antioxidant activity of the samples. So what does it actually do? It measures the color change from violet color to yellow color. Okay, so DPPH activity also have two approaches. First is qualitative, and the second is quantitative. So in qualitative assay, we have spot test method, we have microplate reader method, filter paper method, HPTLC DPPH activity method. And in quantitative, we have UV spectrophotometer, which is most commonly performed, IC50 determination, and electron paramagnetic resonance spectroscopy. So out of which today we'll be focusing on qualitative assay that is been performed using HPTLC with DPPH activity. Okay, so why HPTLC for DPPH activity? The major advantage that HPTLC gives us is that onto a 20 by 10 plate, you can apply 15 different samples at a time. Also HPTLC offers a direct visualization of antioxidant activity on the plate, which means once you have applied, as you can see in this image, once you have applied the samples onto the plate that you wish to analyze, after application you will develop the plate. So this is what the developed plate image looks like. And once this developed plate is been derivatized, or you can say dipped with an DPPH reagent, that to study the DPPH activity or the antioxidant activity, this is how the plate looks like. So that is the reason why HPTLC for DPPH activity is, because at a time you can apply multiple samples, followed by it also gives you the direct visualization of antioxidant activity, because onto the purple or the violet background you can see the separated yellow bands onto the plate, and it requires very less solvent and the sample, and also within an hour you can get the results. Okay, HPTLC also gives you cost effectiveness, making it popular choice for assessing the antioxidant activity of your component of your samples. Okay, so next we'll see steps for performing DPPH activity using HPTLC. So you have your sample, let's say you have your herbal samples. Okay, then once your sample is ready, you will go for application. So this is the instrument that is used for sample application. So once your application is done, after application, you will go for chromatographic development. Whatever samples you have applied onto the plate, you will be separating it into this development chamber. This is a twin trough chamber. You also have automatic development chamber for the chromatographic development. After that, you will take the capture the image in this TLC visualizer to see the response in three different illuminations. This TLC visualizer gives you gives you the illumination, plate image illuminations at three different modes: 254, 366 and white light. Okay, and once this is done, if you wish, you can go for you can go for scanning of the plate. Once scanning is done, now you could assess the antioxidant activity of your samples that you wish to do. Okay, so for that we have this immersion device. Okay, so for that we have this immersion device. So for that we require DPPH reagent. So DPPH reagent, as it is violet in color and it is light sensitive, so what you have to take the precautions while preparing the DPPH reagent is that preparation of the DPPH reagent is very simple. You have to just prepare 1000 ppm concentration, which means you have to take let's say you have to prepare 200 ml of the reagent. So just take 200 mg of the DPPH reagent and dissolve it in 200 ml of ethanol. Okay, you just need to sonicate it for a few minutes so that the particles won't accumulate. So after complete preparation, or once your reagent is completely prepared, you can now pour that DPPH reagent into this immersion device. Okay, immersion device, and then you have to dip the developed chromatographic plate into this immersion device. Okay, so once you develop the plate, you could see the bands that are being separated, or the components that are responsible for giving the antioxidant activity of from your samples. Okay, so once you dip the plate into this immersion device, now you could again go for image documentation with this TLC visualizer instrument. Okay, so we'll have a live demo like how to perform this process, but in our lab we have also performed one analysis that I would like to explain. So so this is the example: HPTLC fingerprint analysis and antioxidant profiling of Indian herbs using DPPH activity with ChemAg HPTLC system. Okay, so here what we have done, we have taken 6 different Indian herbs, and from that six different Indian herbs, we have tried to assess the antioxidant activity of my components, of my samples. Sorry. So here we have taken fennel seeds, jaswan, tulsi, pudina, ginger, amla. Okay, and what we have tried to do, we have tried to screen the antioxidant activity of the Indian herbs. Okay, so as I have said that during this analysis, I have prepared the samples, I have developed my plate with HPTLC instruments, and to study the antioxidant activity of my samples, I have dipped the plate into the DPPH reagent to check the components that are responsible for the antioxidant activity. Okay, so what this HPTLC with DPPH activity gives me, it gives me highly effective for screening the so it is a highly effective technique. It also tells me about antioxidant activity as a yellow bands onto the plate. And this HPTLC with DPPH, it is a very sensitive, efficient and cost effective technique. So here we are qualitatively assessing the antioxidant activity from my sample. Because of its simplicity and very high repeatability, we are using this technique, HPTLC DPPH technique, for assessment of the antioxidant activity. Also, apart from that, we also have one example that CAMAG has performed HPTLC screening method for antioxidant properties of the substances in various matrices using DPPH. Okay, so here they have used the different standards and samples, and they have screened for the flavonoid containing drugs with DPPH. As the herbal samples, they are in the herbal samples there are secondary metabolites like flavonoids, phenols, triterpenoids. They are responsible for giving. They are rich. So these herbal samples, they are rich in these secondary metabolites, and these secondary metabolites are responsible for giving the antioxidant activity. Okay, so similar example, they have used the different essential oils to study the antioxidant activity. Okay, so this is how HPTLC with DPPH assay is performed. We'll see the demonstration about this analysis of different Indian herbs, and then okay, sorry. So now we'll head for the live demonstration of DPPH assay. Here, what we'll try to study the antioxidant activity of some of the Indian herbs. Okay, so let's start. Okay, so now we'll see the live demonstration of for performing DPPH assay. So you must have seen in the presentation, our samples are already been kept ready. First step is the selection of the stationary phase. So you can see This is the TLC silica gel silica gel 60F 254 stationary phase. So for today's analysis, we will be requiring 20 by 10 centimeter. So for today's analysis, we will be hello. Am I, okay. So first, 1000 ppm, 100 mg, 0.02. ಅಡವಿಗೆ ಅಡವಿ camera is this visible? Yeah, it is visible. It is visible. Pakka. The sharing screen? Yes. Is it not seen there? You have to use the camera to the camera. Camera. Wait a minute. Wait a minute. इसका अभी साइड में लिखा है फाइल में स्क्रीन शेयरिंग कट कर विंडोज 8 टेस्ट बना Sorry for the delay. We were facing some technical issue. So as I've mentioned that our samples are being kept ready. Now we'll select the stationary phase. So this is the TLC silica gel 60F254 stationary phase. Onto this stationary phase, we will apply our samples. So we'll mark the stationary phase with 70 mm so that we have to develop our plate up to 70 mm. So So this is the Camac Automatic TLC Sampler 4, which is used for the sample application. So you can see I have kept my samples in A1 rack. So there are 5 different samples. With the help of the syringe, the samples will be applied onto the stationary phase. Also, you can see there are 2 bottles. One is the waste bottle and other is the methanol bottle for rinsing of the for rinsing of the syringe. अरे एक पहले दाखव ना. एक सॅम्पल. So here the rinsing of the syringe is been happening. So our first sample is been applied. So this is how your samples are applied onto the stationary face. You can see the samples are applied into the form of band. Till these five samples are applied, we'll prepare the mobile face for the development. So using this solvent, we will be preparing the mobile face. Ethyl acetate, acetic acid, formic acid, water. And this is the ratio for preparation of the mobile face. So we have already prepared the mobile face. So after preparation of the mobile face, now we'll keep the chamber for saturation. So this is the saturation pad. This is the Camac twin trough chamber. You have to pour 20 ml of mobile phase in the front side. You have to close the chamber and seal the chamber up to 45 degrees so that the mobile phase will divide into 12 halves and 10 ml in rare. So you have to rest this chamber for 20 minutes. So this is the demonstration. So for that, we have kept our applied plate ready. So this applied plate will go for the development.
As you can see, the mobile phase is as you can see, the mobile phase is rising over to the stationary phase, and the components are being separated from your samples. So for the development of the samples, we have used this mobile phase. So this is how the developed plate looks like. Now we'll be capturing the plate image of this developed plate within the ChemAg visualizer too. As you can see, you can capture plate image under three different illuminations: 254, white light, and 366. So as we have captured the plate image under three different illuminations, now we'll proceed for DPPH activity. So to perform DPPH activity, we will require DPPH reagent, ChemAg immersion device. So before performing DPPH activity, we have to ensure that the chamber, dipping chamber is been covered with aluminum foil as DPPH reagent is light sensitive. So now we'll pour this DPPH reagent in the dipping tank. Before pouring the DPPH reagent into the dipping tank, please ensure that lights are off. Ensure that you have a clean funnel to transfer the reagent into the dipping tank. Ensure that you at least have 200 ml of DPPH reagent. So I have poured my reagent into the dipping chamber. Now with this clamp, I will hang my stationary phase. So once your plate is hang onto this immersion device, now we'll click on start button. The plate will go inside this dipping chamber and will within 5 seconds it will come out. So after that you will be able to see the yellow spots onto a violet background. So you could see the separated bands that we have achieved during the development after performing DPPH activity of that samples. You could see the yellow bands onto the white background, which indicates the antioxidant activity of your sample. So we'll dry the plate a bit. We'll keep this plate in a foil and cover it with the foil so that the reaction will happen, and we'll keep this foil into a dark condition for up to 1 to 2 minutes. I suppose the reaction time is been completed. Now we'll go ahead for image capturing. So this is how plate looks like. So now we'll go for capturing of the plate again in Kamak Visualizer 2. DPPH ऍसिड नंबर काय आहे? साधा DPPH ऍसिड आपण कॅप्चर होताना दाखवू. होताना दाखवू. फायनल तुझी प्लेट कुठे आहे ते सांग. फायनल मॅडम रिजन त्याच होतं त्याला सांग खाली जायला दाखवायला. So So after capturing the plate image, we'll see the plate image in Vision Cat's software. So we have captured the plate image. So as you can see, we'll see the actual demo result that we have got. So this was our applied plate in three different illuminations: white light, 254, 366. After development, our plate will look like this. So here we have applied 5 different samples. You can also mark the band. And after performing the DPPH activity, this is how the plate looks like. So so as you can see, the yellow bands onto the violet background evaluates the antioxidant activity of your sample. Okay, so in our software, we also have that feature, comparison viewer, where if you are, let's say, you are interested in only these 3 samples, you will select the track that you are interested in, and then you will simply click on export to comparison. Also, using this software, you can also generate the report of your sample analysis. So you have to click on report. Click on report. So this is how Vision Cat report looks like. It will have the sample details, plate images, developed plate images, scanning data, and everything. So thank you. Any questions?
In DPPH, जैसे can we measure quantitatively antioxidant?
Sorry,
Sorry,
sir,
sir,
will
will
you
you
repeat
repeat
your
your
question?
question?
Can we measure antioxidant in quantitatively?
Sir, with HPTLC, we cannot, but you can study the antioxidant component. Like you can characterize the antioxidant component that is been separated from your sample. So for the quantification, you can go for UV visible spectrophotometer.
Okay, thank you.
Yes.
Hello, can we scan the plate after developing the yellow bands with a suitable wavelength responsible for or responsive for
Yes,
yellow
sure.
light?
Yes, sure, sir. You can scan the plate.
And then we can
Yes,
get
sir.
arbitrarily get the area, so that by checking, suppose by totaling the areas of all the bands of particular sample, because all the yellow bands are indicative of antioxidant activity. So by totaling the area of all the yellow bands in a particular peak, and suppose a sample gives suppose 2000 or 3000 arbitrary unit for one sample, and if the another sample, its yellow band gives above 6000, I mean, we can have a primary assessment before going for a quantitative assessment by UV spectrophotometer. We can have an idea a particular sample is more antioxidant activity than the others. Is it right?
Yes, sir. What you are saying is right, but it will be it can be used for primary identification before going for
Exactly.
spectrophotometer. Yes, right.
Exactly. Okay. Thank you.
हेलो
yes, sir.
अरे वैल्यू कितना है उसका आता है एग्जैक्टली
Sir, in the Vision Cat software, no, you have that RF tool where you can manually assign the RF to that the separated samples. Also, to know the exact RF, you can scan the plate at 517 nanometer.
आई एम नॉट आस्किंग दैट इज देयर इज different RF values with sample with different sample or the DPPH activity has only a specific RF value.
No, sir. It depends on separation of the different bands. As you get different bands on different position, the RF value will vary. It is not fixed.
Okay. So can you can you assess, or can you are you saying that all the yellow bands bear the antioxidant activity?
Yes,
Right?
yes, right.
So you have to consider all the yellow bands.
All the yellow bands, right.
Whatever may be the RF.
Yes. Irrespective of the RF. Yes.
Exactly. Thank you.
Hello.
Yes, sir.
So we are from Dr. PDKV Akola. I have already put of Dr. Gorade to contact from your side. Okay.
Yes.
Dr. Gorade. So there is some grants are available for purchase of HPTLC. I have already um, s- give introductions about HPLC when I present the turmeric curcumin and derivatives. It is the work done with your collaborations at Mumbai. Okay.
Yes, sir. Yes, sir. I remember.
Yeah.
Yes.
Yeah. So I have already told to Dr. Gorade. So you go to purchase
Okay,
this
sir. We
instrument.
will inform, sir, our respective salesperson. Yes.
Yeah. Okay. So is it possible from herbal tea prepare here
Yes,
some
yes,
herbal
sir. It
infusion?
is quite possible as tea sample is quite rich in polyphenols, phenols, and flavonoids. It is quite possible. No
Yeah.
problem.
We have prepared 6 sample here.
Okay.
So is it possible to analyze there?
Yes, sir. We can share our method, sir, as well. You can use the same parameter sample preparation, reagent
Yeah,
preparation.
because we have not that instrument presently.
Okay, no. Okay.
Okay.
Oh,
Thank you. But presentation is good. Okay.
thank you, sir. Thank you.
Yeah. Okay.
I mean, the thing is that you have to develop a good mobile phase, good separation and everything. And
Yes, sir. Generally, the compounds which are responsible for antioxidant activity are phenols, flavonoids,
yeah,
polyphenols,
so you have
tannins,
to go
and
for a
terpenoids. Yes.
highly polar mobile
Yes.
phase.
For terpenoids, you can use toluene ethyl acetate in the
Yeah.
ratio 9:1 like that.
Yeah, volatile is no problem. But
Yes.
for the other cases, you have to get the bands separated in a very good manner.
Yes. Any other questions?
Hello, I have one question.
Yes.
Suppose if we check the skin after derivatization and we check it MS, can we quantify it after using MS?
It cannot be quantified by MS, but yes, you will get the mass of separated band, which is responsible for that particular antioxidant activity.
But you have to do it before derivatization.
Even after derivatization, also it can be done, sir. The half plate can be derivatized with DPPH reagent, and on the same RF, you will have to mark on underivatized plate. Yes.
Exactly. I mean, that's what
And
I mean.
those bands you can take to MS.
Yeah.
Oh, thank you.
Yeah.
Hello.
Can you share this method of
Yes,
DPPH
sure.
via
Sir, we will soon
email?
publish a video on antioxidant activity, as well as we are going to publish application note as well, in which we will give all the details that we can share with you.
मैडम आपका नाम क्या है? मैं जरा आपका नाम भूल गया मैडम.
Dr. Manjusha, sir.
हाँ, correct.
Speaker
पूरा
is
उसको
Miss
दिया.
Vaidehi Ambekar. Myself, Dr. Manjusha.
विश्वजीत.
Vishwajit is also here.
विश्वजीत.
Yes, Vishwajit.
Hello.
Yeah. Yes.
Is this 1000 ppm DPPH concentration is applicable for all the samples, whether it is a standardized procedure?
It depends on, ma'am. If you go through the research papers, no, there are various concentrations reported. So that is not a fixed one, but generally we have used higher concentration, but you can use less than that as well. That also works.
Okay.
And you can run a positive control also. I mean,
Yes. Like gallic acid,
like
ascorbic
gallic
acid.
acid
Yes.
or whatever may be, so that it is also will be giving the same yellow band.
Yes.
So you can validate.
Tocopherol. Yes.
Yeah, you can. So the method you should get validated and get validated.
Okay, thank you.
Any other questions?
Can you share the mail ID of your application lab so that
Lab at, okay, I'll write it down. Okay, lab@anchrome.in.
okay.
Sir, can I ask one more doubt?
Yes, yes.
How was the concentration about the samples?
Sample concentration. See, it depends on how that particular plant is rich in antioxidant activity. Generally, we start with 100 mg per ml as per USP protocol chapter 203. But you can increase or decrease the concentration. If it is highly antioxidant, if it is rich in antioxidant activity, you will have to use less concentration than that. Sometimes it may work with 10 mg per ml as well. So starting concentration, you use 100 mg per ml methanol, and depending on the antioxidant activity, you can increase or decrease the concentration.
And the best
Do
way
we
is
have
that some sample will, as she rightly pointed out, like Trubala or the tannin rich,
Yes, yes.
it will be concentrated. In that case, you have to spot at multiple level, like 10 microliter,
Yes,
15 microliter, like that. You can make adjustments at that time.
yes. Concentration and volume optimization is
Yeah,
one of the
exactly.
part. Yes.
I mean, the good peak resolution and the peak difference of spots, and that track you can take into consideration and
Yes,
make the
yes.
SOP like that,
Yes, yes.
depending
Very
upon the
correct, sir.
sample.
Yes.
So are there any more questions?
Do we have any published articles based on this procedure?
Yes, published articles are there. If you go on CAMAG website under application note tab, you will get application note on this antioxidant activity, in which they have described entire method, what mobile phases can be used, reagent preparation, concentration, everything is there in that application note. And it is freely available. You will have to just register on CAMAG website. The application note is freely downloadable.
Okay. One more doubt is there. You
Yes.
spotted your sample in twice, no? Why that same sample spotted in twice? What's the difference between first track and second track?
Vaidhi? One second, ma'am. Hello,
Yes,
Vaidhi?
ma'am.
Huh. She's
Can
asking
you?
question related to analysis. Can you
Okay.
go back to that slide?
Yes, ma'am. You're talking about this slide, ma'am?
Yeah, same sample spotted in twice, no?
Yeah,
Why?
ma'am. We have just duplicated. We have just duplicated the sample. Like
Just
first,
replicates.
yes. To when you for the sample application, no, we go for usually lower microliter, mid microliter, and higher microliter. Okay.
Because sometimes there may be the bending of the tracks can happen.
Yes, after development, we would have that necklace effect, so that if your one track fails, you still have the second track.
Exactly. And one more thing, as I told you regarding the scanning of the tracks, it just gives an idea, because this color spots, no, if you during second scan, the area may change because the
Yes,
reaction
yes.
has happened, no. But
Yes.
it will give you definitely an idea about that. After that, you have to go for UV
Exact
spectroscopy.
quantification by scanner, yeah, by other technique. Yes.
Yeah, exactly.
Any more questions? I hope the session was informative. Thank you all for attending this webinar and giving us an opportunity to present this webinar. If you have any questions, you can write us at to lab@anchrome.in. We will revert back to you.
Thank you. Great.
Yeah.
Thank you.
Thank you.
So
Thank you
much.
for watching.
Thank you.
We are going to end this session. Thank you all.